Okay, good morning guys. So, padayan lang kita. Topic is, I think this is still in potential energy. So, number 7, last problem for potential energy. For its size, the common flea is one of the most accomplished jumpers in the animal world. A 2 millimeter long, 0.5 milligram critter. So, this is the flea. So, mga flea yan, mga insect. Critter can reach a height of 20 centimeter in a single leap. Neglecting air drag, what is the takeoff speed of such a flea? So, for speed, so yung problem, you can of course use kinematics or with these topics, so you only have to calculate for the change in potential energy. What is the takeoff speed? Potential energy relating it to your kinetic energy. So, that is conservation of mechanical energy. Ani mula may dadidang nga part, ani mo potential ng kinetic. So, let's plug first that equation. So, unlike the last one, which is somewhat may the other. Diba? Ani mo non-conserved because you have a motion in a circle. Usually, amo lang iya case liwat. So, kitaan na lang niyo. So, you have a flea. So, that flea. O, tuldok lang akong flea. Diba? Butang kong pako siguro. So, it can jump back. So, waray man niya matter ton kuan. Waray man niya matter kung anot iya. Amo na niya, pumitik. Diba? And then, that direction is ano to kay rayo? Uh, speed of 2 centimeter. So, this is 2 centimeter. Tapos, it nga imufli has a mass of 0.50 milligram. So, mass sa nimufli is 0.50 milligram. The question is, what is the velocity O? Ini din velocity O or that velocity as it jumps para ma-reach niya at height nga 0.50. So, kung mag-potential energy kita, ano itong equation, K1 plus U1 is equal to K2 plus U2. So, kung starting from rest, VO, sorry, may dahiya. Kaya niya gin-measure, ang paka-jump na niya, di rin nabulig an imo pag an instance nga pag-apply niyan force. Di rin bulig. Dito nakitahan imo, na-apply na niyan force, then nagkamay yan velocity O. Amit wala niya ibutang ha, nagtikang kuno at rest, di ba? Wala man niya magsiring. Yun. So, kitagot niya nga problem. Kaya danay may mga isod nga problem, kin ko consideran iya before nga maka-apply iti nga VO. So, now, that VO is has velocity and then probably an imo V2, kaya ang pinaka-highest man, that V2 would be 0. So, kung an imo velocity to 0, an imo ito kinetic energy 2 is 0. Okay? And then your potential energy 2 is mayda, your potential energy 1 is 0. Kaya waray ka pa height kang ha floor. So meaning you have a balance of K1 is equal to U2. So what is K1? That is 1 half MV1 squared is equal to MGY2. Okay? So that is an MGY2. So the question is, what is the pakianan niya? The question is, what is its take of speed? So the VO, in V1. In this case, that is V1. Or VO in any other problem. Oh. Anyway, so you have V1 squared is equal to 2 GY2 all over M. So, may M ka dida, MGY2. So, cancel an M. You have the 2GY2. So, V1 squared would be equal now to the square root of, sorry, wala na squared. So, again, square root ko na. So, that is 2GY2. 2GY2. Derecho. So, that would be the square root of 2 times 9.80665 meters per second squared multiplied by your height, which is 2 centimeter. That would be 2 times 10 to the negative 2. Again, that is the centi, and then I'll put meter para diretso. Okay? So, square root of 2 times 9.80665 um, times 2 times 2e negative 2. And that would give you 0.63 into significant figures. 0.63. I think two significant figures at kailangan. Oh, you have two significant figures. Oh. So you have to have a 0.63. 0.63 meters per second. So that is V1, the initial speed. Okay. So letter B, kaya pala letter B, di pa masod kay labat oras. Calculate the kinetic energy of display at takeoff, and that's kinetic energy per kilogram of mass. So tiya kinetic energy, kinetic energy haimo 1 pag take off, that would be 1 half mv1 squared. So we only have to substitute 1 half ano imo 0.50 milligram. So that is 0.50 milli is times 10 to the negative 3 milligram. Diba gram? So makonvert ka paghapon niya. So, 10 to the negative 3 milligram. Pwede ko na i-gram din pero pwede ako mag times 10 to the negative 3 tapos times 10 to the negative to the positive 3. So, ini nga duduha equal to 1. Tapos bubutangan ko hin gram. So, kaya sa nagbutang kayo ni kay himong ko kasi nga kilo. Okay? Padayon na ako. So, and then you have your V1 to be V1, so that's already computed. So that is 0.63 squared. You have your meter squared per second squared. So 1 half 0.50 exponent negative 6. So the negative 3 nga negative 3, that is negative 6. Tapos bubutangan ko inihin kilo. Adi ang kilo. Okay? So diretso na ako. Times 0.63 squared. Tapos, meters per second squared is bubutlag ko meter. So, para thermokinetic energy would be in joule. So, that would be 0.5 or 1 half times 0.5 exponent negative 6 times 0.63 squared, period. Okay? And that would give us kilogram Newton meter. That would be joule. So, that would be a 9.9. 9.9. 9.9 joule times 10 to the negative 8 times 10 to the negative 8 joule. Of course, kay crater man hiya. So, actually, amo ito gimpapakalculate ani mo per mass. Okay? Yaha. Square root of 2 times ano yan. Kitaan ko lang kay kasi sa significant figures nag-inubos. Punit negative 2. Store A. Tapos, 0.5 times 0.5 exponent negative 6 times alpha A squared. Tapos, 9.8. Actually, 9.81 or 9.8. Pa daw, nalalaptan na 9.8. Kaya kasi gumamit ako naka-round off na. So, kailangan talaga adit ibubutang. So, and that will give you a 9.8 times 10 to the negative 8 joules. So, I think, sa nga problem, papakalculate an per kilogram. Calculate the kinetic energy take off and its kinetic energy per kilogram. So, kung i-divide mo na yung kinetic energy per mass, so that would be the kinetic energy per kilogram of mass. So, para ma-relate natin, ngadtuha ka ng tawo. Usually, ang problema. Para ma-relate natin, kaya bagay ko kumpara din ni Anfling ng tawo. Yes, guti ira, pero dakot ira energy per kilogram of mass. So, you only have to divide this 0.98 times 10 to the negative 8. And joule is kilogram meters per second squared meter divided by di ganit joule. Pabayanta na lang. Sorry. Control Z. Mong ko na lang joule. Tapos divided by kuan iya 0.50 times 10 to the negative 3 times 10 to the negative 3 kilogram. So sugad na diretso ko nala. Kaya again adi an ay negative 3 ang pareho di. Di ba? So that would give you per kilogram. So divide it by 0.5 times 1 e negative 6. So that would give you 0.2, 0.196. So that is 0.2 joule per kilogram. Okay. And then, sige, puputong ko kay mahilaban na. Thank you guys for listening. Okay, I think may kamay lot ako nga. Ano ba? I think ang akong gingamit is 2 cm. So, I don't kula ka ng piece at akong solution. Hindi nga side. So, that should be a 20 centimeter. So, kung 22 hiya, nadalagan inihin. Anyway, amo na ganun niya. Again, di ba? Gusto niyo sa nagsusurat. Di ko na para makakita ka mo talaga. Anak ko lang din malakas na video. Kailangan, badala mo ito kinahimuluwat. So, that would be square root of 2 times 9.80665 times 20 exponent negative 2. And that would give you, at least kung ada na board kasi, kukorreksyon na niyo, di ba? Mamaram na ka mo, di ba? As humble as I am, I want to be corrected. Ay, pinaspasa lang sa akon. So that would be 1.98 into significant figures, that would be 2.0 meters per second. So if that is 20, so it's a shift store A. Diba? Tapos, of course, kung may mali didi, kay kunin niya. Actually, 1.90. Gimbutang ko niya nga, ginalpa ko. Kaya bangin nag-iiniba na tiya significant figures. Actually, 1. Or kapihan niya 98057. 98057. Tapos sige squared. Okay? 1.98057. So, napira. 0.5 times 0.50 exponent negative 6 times alpha A. Alpha A lang ako didi. Or that 1.98. O 2 actually didi. Pero dapat kimbabalik ito niyo paggamit. An iya waray ground off. Okay. A squared. That would give me 9.8 to the negative 9.81 to the negative 7. So may negative lat akon. Negative 7 akon la didi. So negative 7 joule, same 9.81, actually 9.80. 9.81, pero kung to significant figures, that would be 9.80. So divide it by 0.5 exponent negative 6, and that would give you as 0.2. 2. So diri 0.2 bat 2. 2 joule per kilogram. Okay, just a correction. Thank you guys for listening.